When listening to these videos, it may be helpful at different points to pause the video and try to determine what the next step is, and then resume the video and see if your step matches what I do next. So this topic is converting between logarithmic and exponential equations. One way of understanding logarithmic equations, or logarithms in general, is in connection with exponential equations, or exponents in general. So we see here, this is a topic from Alex, our sample problem. Rewrite this exponential equation here, 8 squared equals 64, as a logarithmic equation. And so the two are related, and the base is going to be the same. So the base of this exponential equation is 8, and so when we write it as a log, it will be log base 8. And then of 64 equals 2. And so we see the base is the same. The exponent here is going to show up here. And then the value is what we're taking the log of. And so similarly, if we have log base 8 of 64 equals 2, we can rewrite that as, again, the base is 8, and then the power is, to the second power, equals 64. So the base remains the same, and then the argument and the answer sort of switch places. 8 squared, so we're squaring it, so that becomes the answer for the logarithm, equals 64. So the 64's answer, it becomes the argument for the logarithm. So let's take a look at another one. So we'll start with an exponential equation. Let's say 2 to the 5th power equals, and of course 2 to the 5th power equals 32. So we can rewrite this as a logarithm. So again, the base stays the same, and so we have log base 2, and then the exponent comes over here, and the answer comes over here. So log base 2 of 32 equals, and that equals what the exponent is, which is, say that equals what the exponent is, so that's going to be 5. And likewise, we could rewrite this logarithmic equation as an exponent. The base stays the same, 2, and then my exponent comes here, to the 5th power equals 32. So that is, these two are equivalent to each other. If you can write something as an exponential equation, you should be able to write it as a logarithm equation. And so this is also true for more complicated exponentials. So for example, 3 to the negative 2 power equals 1/9. We can rewrite that as log base 3 of 1/9 equals the exponent, which is negative 2. Or we could write, let's do it. So if we have, so 5 to the 0 power equals, well, what's 5 to the 0 power? Well, that's 1. So we have log, again, base 5 of 1 equals the exponent, which is 0. And then we could rewrite it the other way if we wanted to. 5 to the 0 power equals 1. All right, so this is pretty straightforward. You should be able to do this pretty easily with a little practice, but this is really helpful in evaluating what logarithms are. So when we evaluate logarithms, if you can't evaluate it, then sometimes it helps to rewrite them as an exponential equation, and that's the next topic I'm going to do.